Why are patterns with symmetry beautiful? Unique designs created by nature have a lot of secrets. Although a unique design may look very simple, it has went through many trials, errors, and completed through imagination and endeavor. Patterns that are shown in nature are exactly the same. In nature, there are many patterns where similar shapes repeat. The stripes on zebras, human fingers, and arrangement of spines are all patterns. Some people argue that the patterns of nature, which seem to be created by a set of rules, are the result of probability. The widely known Turing model is named after Alan Turing, a British mathematician who proposed a mathematical formula on the mechanism of generating zebra stripes. He discovered that zebra stripes are formed at regular intervals by alternative workings of a chemical substance that causes patterns to appear on the skin and a chemical substance that hinders their appearance. Based on the Turing model, scientists studied the developmental process of organisms' patterns. For example, the blue-green algae, which had been existed before plants appeared on Earth, is a primitive organism that are single-celled, forming filaments. The main function of blue-green algae is photosynthesis, the process that creates oxygen using sunlight and stores the created energy in the form of carbohydrate. Just in case there is a lack of protein which is essential for survival, blue-green algae accumulate nitrogen. Although cells may share 100% identical genes, the amount of proteins that each cell can produce is different. This phenomenon is called noise. The original Turing model requires sophisticated and minute adjustment to finally complete patterns. However, when applying noise, the developmental phenomena of patterns can be explained. The probabilistic Turing model was developed by applying noise to the Turing model. The numerous organisms' patterns that look alike they are designed very firmly are the result of the calculation of the numerous noise and probability. As a result, organisms spend much more energy to pass the information of their own patterns on to the next generation. When asked what they think is the most natural patterns, most people would say primitive patterns through their observation of nature such as the sun, moon, stars, grass, flowers, insects, and animals. This is because there are harmony and balance in nature. The creation and extinction of nature is always in balance and coexist in harmony. When looking back at human history, symmetry was the word that represents beauty, order, and perfection. The human face looks the same at the surface even though the left and right sides are switched. In addition, the shape of snowflakes in a hexagonal shape is the same when it is rotated by 60 degrees. The source of the beauty of nature is in the symmetry, and the principle of symmetry is widely used in various fields like arts and biology. Even by looking at beautiful pictures or sculptures, it is possible to know that symmetry and balance is the source of the beauty. Symmetry is a mathematical concept that is placed under every symmetrical structure, starting from the harmony of ratios to points, lines, and rotational symmetry. Earth, where humans live, is a beautiful piece of art. Earth is structured so beautifully and it is the best work of art that functions according to the beautiful rule. Mathematics, which started from Greek natural philosophy, is the process of discovering the beautiful secrets hidden in the universe. The beautiful universe consists of rules and laws that pass through the smallest of the materials to the massive universe. The minuscule phenomena that occur in nature and the things that exist in the massive universe are not just irregularly created and annihilated. They are all beautiful and great artworks that are formed based on certain natural rules and laws to delicately move and operate. From a religious perspective, God is regarded as an artist who created the universe, but in the world of mathematics and science, it is rather the beauty itself that follows the physical rules based on numbers operating on all creatures. The world of matters was developed from the consideration of the smallest unit. Most phenomena encountered in everyday life, including the basic unit of material that are inside of the human body, are a big physical cast in the principle that goes through the massive universe. The human aesthetic and artistic senses are no exception. String instruments play the best chords when the lengths of two strings are in a simple integer ratio. And also, the most harmonious sounds are played when the strength of the tension is in the ratio of the square of integers. The harmony of sounds is a phenomenon caused by the operation of completely different concept called a number. Most people probably played with Lego at least once in their childhood. With many basic blocks in various shapes, it is possible to make many forms of cars, buildings, and even people. Lego comes from the Danish phrase, "legoth," which means play well. In Latin, it also means I study and interlocking pieces together. Why is Lego loved by people of everywhere, transcending time and space? It is because countless patterns can be created only with the basic shapes of Lego. The reason for studying the beauty of pattern and symmetry and basic shapes is because understanding the patterns in nature can create things that make human life more comfortable and beautiful. Among the shapes discovered in nature, some feel more beautiful because of many symmetries in them. Leaves show bilateral symmetry, flowers also have symmetry. Not only humans, but animals also exhibit bilateral symmetry on their body. Symmetry is the distinct characteristic that every organism have. What would happen if the human body is not symmetrical? If the lengths of two legs are different, it will be very unnatural and uncomfortable to walk or run. In addition to this, it will be almost impossible to lift up an object using two arms with different lengths. The appearance on the surface would look very strange when an object is not in symmetry. Symmetry is also very important in the high-tech industry. With the different lengths of the left and right wings on an airplane, it cannot fly straight. The asymmetry can lead to a big catastrophic accident that could ruin many lives. As such, symmetry is a very important concept dealt in everyday life because it is directly related to human life. It is not a coincidence that symmetry is contained in patterns revealed in nature. In order to live a more safe and efficient life, the best method that organisms chose is to have a symmetrical shape. If mathematics is understood as an elegant language that reads patterns in nature, then it is possible to understand why this topic has to be carefully studied. Advanced technologies that make people comfortable can be created by understanding the symmetry in nature. What was the basis that nature created a beautiful hexagon? From a mathematical perspective, a hexagon is very useful shape. Among regular triangles, regular square, and regular hexagons with the same length of sides, regular hexagons have the largest area. Although circles have a larger area than regular hexagons, circles create empty spaces when aligned with other circles. Yet, regular hexagons fit perfectly and create no gaps. Honeycombs, which are highly valuable to bees, are nature's creation that shows the characteristics of regular hexagons. Honeycombs composed of regular hexagons with no gaps can store the most honey because rooms are tightly attached to each other without creating empty spaces. Regular hexagons are very useful in terms of space efficiency as well as making beautiful patterns. Moreover, compared to other shapes, regular hexagons create more varied patterns. The structure of regular hexagons interlocked to each other creates a mysterious atmosphere by making different kinds of patterns, including vertical, horizontal, and both diagonals. Two types of symmetries can be found in regular hexagons. They are the rotational symmetry, which is made by the rotation of 6 angles, and the reflection symmetry, which creates two identical shapes when cutting along the line passing through the center. They show the beauty of regular hexagons. Even in the shape of snowflakes, we can see the beautiful symmetry of hexagon within it. When seeing the elaborate picture of an enlarged snow crystals, they feel like a clean and transparent gem. Wilson Alwyn Bentley, an American photographer, had been taking photos of snow crystals his entire life. The fascinating fact is that none of the snow crystal he took had the same shape as one another. Just as humans have different fingerprints, nature has an infinite diversity. There are no set rules in the snowy landscape, but the perfect hexagon is hidden in the small snow crystals. Is there a possibility that humans will be able to create something comparable to the beautiful hexagons made by nature? It is said that beautiful hexagonal snow crystals can be observed if you complement the water before it becomes crystallized. 60 to 70% of the human body consists of water. Saying a positive word to someone can help improve the person's spirit, just as much as the snow crystals. Symmetry have been around before the universe was born. Nothing happened at first, but all of a sudden, everything started. In other words, it means that the symmetry was destroyed spontaneously. The universe was only in two states, symmetry and destruction of symmetry. Today, natural science including mathematics has a foundation in the theory of relativity and particle physics. The theory of relativity developed by Einstein shows that the laws of nature governing time and space is relative according to the observer. Particle physics is one field of physics that studies the basic matters that makes up the universe and its laws. Among all the fields of studies, particle physics investigate the smallest world. The symmetry and its spontaneous destruction are the main subject of study in particle physics. Therefore, it is essential to know the importance of symmetry in studying natural science. At a glance, symmetry might be not visible in the universe. Therefore, it is necessary to find the symmetries hidden in nature upon careful observation. Physics develops a theory based on the time symmetry and space symmetry. Energy is the key for time symmetry and momentum is the key for space symmetry. Because of the need for time symmetry, the law of energy conservation was developed. And, because of the need for space symmetry, it became possible to preserve momentum. In biology, which deals with organisms, the mathematical concept of symmetry is not revealed to the surface, it is just hiding quietly. The human heart is located slightly on the left side of the center of the body. However, in the case of children, the heart is located in the center of the body. To grow up and become an adult means that symmetry breaks through a series of processes. The human brain has a special structure. Its cross-section structure is remarkably unsymmetric no matter which angle it is observed from. However, the curves on the surface of the brain do not have a simple geometrical symmetry just like circles and rectangles have. Seeing that countless short curves are connected together, it seems organisms are fond of curves. Geometry created by the brain is a world like a ball of thread with myriad tangled curves. In particular, because many hills and valleys are on the surface of cerebrum, the size and shape of its cross-sections are different depending on the location of cutting plane. The brain is hard to understand even with the modern medical science. Nevertheless, there is a way of discerning the structure of the brain's cross-sections. It is to find symmetry in the brain structure. In any direction of cutting, the cross-section of the brain is perfectly symmetrical around the axis of symmetry. The brain is a symmetrical structure, and also it is made up of modules. Modules refers to the unit component that make up the finished product or the unit of system. Their functions must be fully defined for the purpose of the entire system. Modules play as the role of Lego blocks. Just like making a windmill or an airplane by assembling Lego blocks, it is possible to build bigger and more complex structures by combining modular structures. The human brain or spine is formed by unit modules being connected. The law of memory is also developed from symmetry and modularization. The world, born out of symmetry and destruction of symmetry, longs for symmetry. The need of symmetry has led to the four forces of the universe: gravity, strong nuclear power, weak nuclear power, and electromagnetic force. Thus the beauty of such symmetry is the origin of these forces. Nature's beauty comes from symmetry. Symmetry refers to both sides being the same when facing each other on a point, line, or plane. When you draw on one side of a paper with paint then fold it in half, the same drawing gets printed on the other side when you unfold it. A symmetry in which the two sides of a point or a line are the same can happen within one shape or between two. Symmetries include concepts of line of symmetry, axis of symmetry, point symmetry, location, and others, as it will be explained in detail. Line symmetry refers to two sides completely overlapping when made symmetrical with a straight line. The two shapes that make up a line symmetry has the same distance away from the axis of symmetry. Because it is a symmetry in relation to a straight line, it is called line symmetry. If the axis of symmetry is inside the figure, it is a symmetric figure for a line, and if the axis of symmetry is outside, it is a figure with position of line symmetry. Symmetric figure for a line has corresponding sides and angles, and the corresponding points are perpendicular to the line segment. The corresponding points are all at the same distance from the axis of symmetry. The axis of symmetry is a straight line in the middle of a line symmetry. The long wooden sticks that is fitted into a hole in the middle of a wheel is also called axis. The axis is straight lines that make up line symmetry. The place that is folded to make both sides completely overlap is called the axis of symmetry. Point symmetry refers to being symmetrical when rotated 180 masculine ordinal around a point as a center. If a shape coincides with itself after a rotation of 180 masculine ordinal centering on a middle point, it is a symmetric figure for a point. The point that is the center when rotating the shape is called the point of symmetry. For some shapes with point symmetry, the center is inside the shape while for some it is outside, a figure with position of point symmetry. Location is a place something is at. A symmetric figure has the axis of symmetry or the point of symmetry inside the shape. But figure with position of symmetry has two shapes with the axis of symmetry or point of symmetry outside the shapes as the center. The biggest difference between a symmetric figure and a figure with position of symmetry is that a symmetric figure has one shape while a figure with position of symmetry has two. Now the question is, can it be a symmetric figure for a line and symmetric figure for a point at the same time? A line symmetry occurs when two sides match exactly when folded on the axis of symmetry. Point symmetry occurs when the figure coincides with itself after a rotation of 180 masculine ordinal centering on a point of symmetry. Is there a figure where both conditions are met? The most representative shape is a circle. When you fold a circle in half, the two semicircles that come out of it is exactly the same. When you rotate a circle with the center as the center 180 masculine ordinal, the shape is always the same as well. A square also meets these traits. Just like today, people in the past pursued beauty. Out of the many conditions to achieve beauty, the most basic is to have symmetry. As mentioned earlier, symmetry refers to points, straight lines, and planes being the same on both sides. If the opposite side is the same with a point is the standard, it is a point symmetry, and if a line is the standard, it is a line symmetry, and if a plane is the standard, it is a plane symmetry. If we look around the nature around us, there are many things that are symmetric. All the snowflakes that make up snow are regular hexagon-shaped snow crystals. There are many symmetries within regular hexagons. Butterflies have wings that have beautiful floral patterns that are all symmetric. Not only do patterns on snowflakes and butterflies' wings have a symmetry, but as we can see on people's faces, flowers and leaves, bugs, and other things in nature, nature has an innumerable amount of symmetry. Symmetry is not a characteristic found only in nature. We can also easily spot symmetry in things humans have created. For example, famous architectural structures around the world such as the Great Wall of China, the Greek Parthenon, and Taj Mahal also utilizes symmetry. Many patterns can be made using a tessellation. Tessellation uses a lot of concepts of symmetry. A regular polygon is a shape where every side's length and every interior angle are the same. A traditional tessellation is made of regular polygons. On a plane, traditional tessellations can be made out of regular polygons such as an equilateral triangle, square, and regular hexagon. When looking at the many designs from the past, we can see that only regular polygons were used on tessellations. However, As tessellations became a form of art through Escher, shapes other than regular polygons started to be used. Tessellations today do not just consist of a repetition of same shapes but utilize mathematical principles such as symmetry, rotations, and reflection to create various things. Dutch artist Escher, 1898-1972, drew many unique captivating drawings using mathematical principles. He was not interested in math or science in his childhood, but because of his meticulous personality he acquired technical skills through carpentry and woodworking classes. We often see drawings with equal division or symmetry of planes being emphasized in his early works. Then in 1922 on a trip to Spain his work style changed dramatically after being fascinated by the geometric patterns decorating Alhambra. The Alhambra is well known for its stunning tessellations. It is so well known that famous design companies send their designers to be inspired by the various mosaic patterns on the Alhambra. Tessellation refers to using a shape to completely cover a plane or space with no gaps or overlapping. It is often seen in block paving, carpets, curtains, clothes, packaging, mosaics, and more. Tessellations can be made through four transformations: a translation, moving a shape the same distance; a reflection, flipping a shape as if reflected on a mirror; rotation, rotating a figure about a fixed point; and a glide reflection, a combination of translation and reflection. Escher was able to make such mysterious works using these methods. Because people are always surrounded by symmetries, they think of it as a natural thing. Then let's take a moment to think about why there are so many symmetries in nature's patterns. Nature does not form symmetries just for the aesthetics. Symmetry is what balances life and the energy that is distributed through it. For example, birds can fly straight because their wings are symmetric. The reason fruits do not easily break when impacted by external forces is because they are a circular shape, the most symmetric shape. As previously emphasized, mathematics is the study of discovering the secrets of nature. Another important note to emphasize is on the fact that every aspect of nature has a reason for being the way it is. Studying and understanding why symmetries in nature's patterns look so beautiful and why nature is in symmetry is the right way of studying mathematics. Can nature's beauty realize the dreams of longevity? Nature always chooses beauty and efficiency. Fractal is a structure in nature that is endless with brilliant colors and patterns, with symmetric geometric figures with dazzling array of colors and patterns. In this sense, we can think that math theories are a form of art. Art and science is so closely related to one another that they are inseparable from one another. In particular, although art exists in nature, they are not an exclusive property of humans. Nature is full of actions by living organisms that cannot be explained only by survival of the fittest. A type of bird that lives in Australia builds unique structures. They do this because the males are trying to attract females to mate. To maximize the visual effect, the males clean up the surrounding area of the structure and decorate it with conspicuous colors. However, because they are easy to spot, it increases their chances of being caught by the predators. Therefore, scientists have said this action cannot be just seen as an act by the males to merely attract female bowerbirds. It is said that beauty is part of a means of survival. Therefore, there is a limit to evolutionism when describing the beauties in nature using just the idea behind survival of the fittest. The civilizations that humanity created was for humanity. Humans are symmetric organisms. One of the easiest objects to see around us that has symmetry is a car. No matter where you look at it, it forms a perfect symmetry. If cars were not symmetric, the air resistance calculation would be different, causing serious problems to the strength and safety of the steel plates as time goes by. Even the interior of the car is nearly symmetric to make the weight of both sides equal. The world of circles is also visible in cars. Circles are symmetric and is a shape that maintains comfort. Tires, which are a circle, provide stability while running with minimum contact with the ground. There is also symmetry in the tires' shapes and the designs of the patterns on tires. Buildings also have symmetry. When you look down at the Palace of Versailles from the sky, it is perfectly symmetrical. The Taj Mahal is a human heritage that highlights the beauty of its symmetry. A Buddhist temple and royal palace in Korea have a bilateral symmetry structure. But strangely enough, houses of ordinary people were often asymmetrical. This is probably because these houses were built in harmony with the natural surroundings. Most ancient buildings have bilateral symmetry. For example, Egyptian pyramids and Mesoamerican Aztec temples are symmetric buildings. Then why are most buildings symmetric? This is because it is pleasant to the eye and easy to build. In an age where there were no computers, coming up with plans for complicated buildings was hard to do. However, symmetric buildings have the benefit of being able to be built as stable structures by just mapping out half of the building. The concept of symmetry is also widely used in the industrial world. Bearings have a sphere form. Without bearings, machines that do circular movement, like wheels, will not operate well. According to scientists, bearings made in space make a perfect sphere shape, so when comparing it to ones made on Earth, it performs much better. Space is suitable to make spheres because the gravity is weak. Bolts and nuts are prime examples of symmetric parts. The general shape is symmetric, not the indentations. Balls used to play sports must be perfectly symmetrical. The bazooka, the match ball used in the Brazil World Cup, has a perfect sphere shape by combining 6 pinwheel-shaped panels. The shape of the 6 panels are all of the same figure. Golf balls have dimples. The golf ball itself is symmetric, but, perhaps to destroy the symmetry a bit, the pits on the surface of the golf ball helps the ball have more energy. Dimples on the golf ball allows the ball fly farther away. Rectangles, not only circles, have symmetry too. A rectangle has a stable and symmetrical shape. Most houses that people live in are a rectangle, and the rooms they live in are often a rectangle. The furniture people use, such as beds and tables, are also a rectangle. People in the West insist on using rectangles, the shape that seems the safest and feels most stable, just like the square aesthetic seen in the Versailles Palace. Human civilization is a history of symmetry. Although the people that made Egyptians' pyramids and the South American Inca Empire temples never came in contact with one another, they look very much alike. Likewise, the Moai statues in Easter Island and Dal Harubang in Jeju Island have similar shape, they just have different size. Symmetry is the most important factor for explaining organisms' functions and beauty. Most living organisms have evolved bilateral symmetry or radial symmetry. For example, most intelligent life like mammals, birds, and fish have a bilateral symmetry shape. The reason living organisms have a bilateral symmetry body is because species with symmetrical forms survived out of the long process of evolution. Species that were not symmetric and had single feet could not survive on the land and would soon go extinct. Here the pressure of survival refers to the ability to solve problems such as how fast can one catch the prey, and how to escape predators and not get eaten. People want to live a healthy life without getting sick. If there was a way to know what diseases we would catch, we can sufficiently prepare for it. Biotech scientists have found that the patterns in genes are symmetric, and by using this can determine a person's health by analyzing the genetic information. Today, active research is being done not just to predict what diseases someone will get in the future, but also in the technology to modify the gene to prevent getting the disease in first place. Mathematics is a study that creates something that can realize people's dreams of longevity. With natural sciences such as biology, physics, chemistry, and mathematics starting to be applied on real life, the neutrality of science value became a controversy. Some have said that although the scientific technology itself is value neutral, value is determined by the people using it. On the other hand, there are also those that argue that because scientific research is done by humans, during the process of research personal values are bound to get involved. Of course, there is no right or wrong answer. Whether scientific knowledge is neutral or not, there is one thing for certain, that when using the knowledge, people's happiness must be utmost priority.